what I'm going to show you is a couple of visualizations for peer-to-peer protocols and kind of like a general idea for libp2p. So I'm probably going to show some of this presentation again tomorrow for the parity folks. So you get 2 rounds of it. But the general, I'm going to show you a demo of something we built for Filecoin, but it's general enough to apply to IPFS and libp2p in general. So this is really a tool for libp2p, meant for libp2p, and for debugging some protocols on top of it. So I'll start with like the general idea that visualizing distributed protocols is a hard thing. And there's been a bunch of like interesting work on this of like how do you reason about some like really complicated thing going on with a whole bunch of like different machines and different roles and messages going through. And so for a long time the conventional wisdom was, hey, you just need to look at log traces to understand what's going on. And maybe if you could actually like take those log traces and visualize them, maybe you could find the bug in like seconds, not days. So not only that, but you could explain how a protocol should function to people in much simpler ways. So there's a bunch of history around this, and people have tried different things. I think I'll call out a really good one for Raft. It's called Raft Scope. And it's part of it's in the homepage of the Raft consensus protocol. Actually, let me make sure that I'm recording my screen. I'll just keep going from here. So this is a visualization of Raft. I can't make this page bigger for some reason. There we go. Whoops. So what's going on here is that you see 5 nodes, and here's the internal Raft timers. They're going to expire, and then they're going to try to get elected as leaders. This one kind of went first, so that was kind of a failed round because multiple tried to get elected at the same time. But now the clocks kind of like got reshuffled, so it looks like S4 is going to win the next election. They're going to run. Oh, yep, there we go. So now those votes are correct, and now S4 is starting to replicate content. For some reason, this is a little bit buggy. It might be that running QuickTime and this at the same time is unhappy. But this is now starting to like replicate this is now like the proper leader. So I think at this point I could enter a value or something. I don't remember how to use this. Actually, I can pause and like resume the whole thing. Here, I'm gonna pause QuickTime because I think it's like totally wrecking everything. Sorry, we're gonna have to like record that another time. Let me refresh. Great. I'm gonna speed it up. Whoa, too fast. I think at this point I should be able to enter values. Maybe not. Anyway, this is supposed to be an interactive tool that allows you to play with the protocol and to understand it. And so you can kill nodes and start adding values to see how the state machine replication works. There we go. Stop. So I just stopped that node. Maybe I stopped the whole thing. Play. Yeah, so now S2 is dead. And then I can bring it back and so on. Anyway, so this is like a live full implementation of the protocol and allows you to kind of think about it and debug it. So what I would like is to be able to do that with not just a different implementation of the protocol in JavaScript, but with the actual implementations of the protocols as they are in live nodes, whether it's Go or JavaScript or whatever. And the way to do this is we can take the protocols themselves and take the event logs from the protocols and extract that trace, combine all the event logs from all of the different nodes, and then use that to then show a visualization. And we could either collect all these traces and keep them and then play back that visualization whenever, or we could do it real time. Like we could actually like visualize something live. So I'm going to show you a version of this implemented. And this is an old idea. So this was like discussed years ago in, 2015. And I think that this was like a very first implementation of this. You could like play it and so on. But I'm going to show you a nicer one. So so this is actually going to spawn a visualization. So the depth chart over there is kind of broken. Actually, I have a bug, so I have to like start with a miner instead of a client, otherwise it won't work. No, whoops. Roll again. What's that? Yeah, no, serious. Like I should just fix my damn bug, or like revert the last change that I did that introduced this. Great. So that's a miner. Ignore the depth chart. That's wrong. And so now each of these is a live Filecoin node in my machine, and they're set to like a second block time, so they're going really fast. And so this is each one of like the money moving is an actual transaction being propagated. Yeah, let me play with the timing. That's a little bit too fast to see. Let's do 2 seconds. So this will now take longer, and now we have to pray that it's like a miner, not a client. No, damn it. Roll again. Survey says. So the whole thing is like, there we go. So what's happening here is that there's a process, it's a simulator, that is picking randomly between a set of choices. And it might spawn a node that joins the network. So every 2 seconds, it like randomly spawns a node, and then it connects it to the network. And then every so many seconds, it'll like throw a random action, and it chooses from a number of actions. So there's like it adds asks, adds bids, sends a transaction, or mines a block. So again, like the depth chart is all totally wrong. So it's a work in progress. But what's going on here is those are actual nodes, and what's getting parsed here is the event logs as they come out of Go Filecoin. And those event logs are then transformed into something that this visualization can consume. So I'm kind of want to kind of walk through that. So I think, so grep.
Can you make the terminal text bigger?
Yeah, I'm just going to try and like, let's see. I'm going to try and hook into one of these. Let me edit the command in a nicer thing. Wait. I think I want event log. Log tail, I think. So I think if I do this, so this is what's pumping out of the Filecoin nodes themselves. And so maybe that node is not getting, so it got like 2 messages out. So every once in a while, like things are happening, and this is pumping out logs. These are all JSON. This is the exact same kind of event log structure that is in Go IPFS. So it's the same idea. And all the Go libp2p code is full of this stuff. So you'll notice that some of these events are actually the same thing that Go IPFS emits. Maybe most of these are Filecoin specific, but a bunch of these are like dials and so on. I guess maybe I silenced those, but what this simulator does is then take that event log and then parse it into this. So these logs are what the web visualization receives. So what's going on is that we're letting the program define its own event log however it wants, because it's gonna, that's gonna change over time, and people are gonna make decisions about how that should be based on what makes sense for that program. And then we write the visualization, and we want to create an event trace that makes sense for the visualization with events that make sense for what we actually want to see. So in this case, it's like nodes entering and leaving. It's like a block being propagated, a transaction going through, and so on. And so you might notice that these are like a lot shorter than the other ones. And so in that transformation, a bunch of logs are being dropped out, and then they're getting transformed into something that the JavaScript can consume. They're also getting aggregated. So each of these nodes, we're taking all of those event logs and putting them into the same pipe, and then pushing it to the visualization on the web. So a way to look at that is, there's all these events that we want to track, and so we have a program and it outputs event logs, and there's a thing called FileNet sim for now that then issues commands, and then takes all the event logs and then outputs it to the logs thing. And I can do this for, and so that includes like a network controller, a simulator, and so on. And I should be able to do that over all of these programs, and I can put in as many as I want. And the cool thing is that not only can this work on a simulator in my computer, this should be able to work over any nodes. I should be able to like grab random nodes, right? So I could actually like refresh this page, and it should like download the entire log history and play it back. So that was that's maybe not what is. So I think like that's D3 choking on like all of the animation sequences, but now it's back to it's caught up, right? And so ideally there would be like a bar that would allow you to kind of stop and play back and rewind and so on. But yeah, this is like hooking into like a live. You could hook this into a live network, and then you could with IPFS we could use this to view our nodes and our gateways and see what they're up to and what kind of messages they're showing. And the cool idea is that we should be able to generate a bunch of different end visualizations that show us different things that we want to see. Like in some cases, we want to just see the DHT and just focus on a DHT protocol. And it's not IPFS specific. It's just libp2p DHT specific, and that's it. In other cases, we might want to see something much more very different. And so we can choose the visualization to target what we want to see. So in this case, we put them all in a ring. But just as easily, we could put them on a map. So we could actually have like a globe and put them there, and so on. And so it's kind of like a very nimble architecture such that if all of the processes stick to this event log thing, and then we have this simulator that can like easily spawn them and send commands and extract those logs and then transform them into what the visualization wants, then we can write like a custom visualization per thing we want to see. And a bunch of these will be reusable components. And the idea is to have something like, you probably have seen blocks from for D3, right? Where people would just write a gist, and then you could see kind of like real D3 magic happening. Ideally, it would be as easy to write one of these like visualization plugins and then run it, like have both, like collect some traces and then run this visualization over a trace and then see something about it. And this helps debug. This helps understand these protocols. It helps you teach you what's going on, and so on. So that's kind of the goal of that tool. Yeah.
Okay, I have another question and a comment. So just want to make sure I'm following the demo. So you have some program called SDSim that's launching Filecoin nodes, and then it's getting their standard out or whatever, and turn it into a simplified format. Then how's it getting to the browser?
So through this /logs.
/logs just some socket or file?
Yeah, so FileNet sim is both. It's a single program that is issuing all the commands and spinning them up, collecting the event logs, and then aggregating them and buffering some of them, because you actually want to keep a buffer a certain size so that you can refresh the page easily. and then exposing them over HTTP. So that serves the assets themselves and the aggregated logs. But all of this could change. This was just kind of a hack to get it together. If we wanted to do this pretty generally for libp2p, what we would want is that central thing to be generic and like be a single program. And then you would probably write another program that either uses that one as a library or is invoked by that one that sends the commands and converts the logs. But we only need to write that one thing, that controller and outputter of logs and so on. We just need to write that one time. And then what a single visualization would do is it would say, I want to filter for these event logs, and I want to transform them in this way. And so what that code looks like is pretty simple. So in this visualization is this part where I just have like this huge switch statement where whenever I see, I ingest the aggregated logs from all the different nodes. And then whenever I see an event, I convert it into a different event. I go from like the event specific to the program to the event specific to the visualization. And so just by applying each of these filters, I go from the implementation specific thing to the thing that my visualization wants. And then we would have to also write the visualization. But that's, I think, kind of unavoidable because you end up wanting a lot of different things. We might have some like reusable components, like if we have the ability to stop, play back, and so on, maybe that can be written once. But visualizing, again, a DHT will be different from visualizing bitswap, which will be different from visualizing pubsub, which will be different from visualizing a lot of this stuff. So yeah.
So that touches on kind of my comment. For the debug use case, what my experience with other distributed systems is the usual pattern is somebody comes in the morning and they're like, okay, we know it failed between 2 and 3 a.m. So they want to go back and watch this simulation for that time period. So I would think we want to buffer actually quite a bit, like 24 hours worth of every node. And then
yeah, but so this allows us to, the simulator and the visualization can be like not running. And as long as you're capturing the event logs from the original processes, which is just standard logging procedure, as long as you're capturing those logs, you can then sift those through the simulator whenever you want. And so you can replay them in the future, whatever you want. So this could also work for test suites. So you could run a test suite, and then if a test fails, and one of its outputs is not just like the standard out, but also all of the event logs. And then you can take the event logs, throw them into a simulator, and then see what's up.
Yeah, that'd be great.
Yeah, and so we could automate a lot of that. So, and this is a visualization that we wrote, and I think it like choked for some reason. I'm like not killing processes, so a bunch of processes hang. So I probably had like hundreds of Filecoin processes or thousands. But I mean, this is like pretty simple. You could see something much more sophisticated, like a 3D globe and like all the things on it, or some other ways of visualizing things. Especially for PubSub with aggregating trees and so on, you could play around with the latencies, and the latencies could show you like the distance on between two nodes, and then you could see the messages propagating through, and so you could see whether is the algorithm forming the tree correctly? Is the algorithm propagating correctly? Oh, like this message is getting through, but like through this node, but not this one. What's going on? It would allow us to do a lot of that kind of debugging. But yeah, so cool. Any other questions? Sweet. Sounds good. That's it.
This is really cool to visualize, as you were saying, going back in time and checking what happens with the system, the distributed system.
Oh, yeah.
It's very useful. And I think the idea of using also the results from testing to visualize what's happening, I think that's also pretty cool. It allows you to speed up development considerably.
Yep.
It's a lot easier to analyze that rather than a bunch of logging information, which takes a long time to read and visualize it in your head.
Yep.
Not everyone has that kind of capability.
Yeah, exactly. And sometimes your model is actually wrong. So you think that something is going on because you've thought about this protocol a lot and you have something going on, but something changed and now something else is going on. And now not only are you like trying to simulate it in your mind, you're trying to debug yourself and make sure that like your mental model is still correct. So yeah, actually using a real visualization would be probably better.
I think there's two distinct use cases here. Like, there's the developer use case that you were talking about, where it's like, okay, this test from 2 years ago failed. Why did it fail? Like, what happened? And then there's a separate kind of operator use case, which is like, I'm running these libp2p nodes. I know they failed between 2 and 3 a.m. I don't know what happened. I don't know why. So I want to replay history at that point in time.
Yep.
So I think it has some utility for both of those
Yep.
cases. Yeah.
And even in a third case, which is this is a great visualization of Raft designed by somebody else, which is so this might be a little bit more extreme, but parts of this is what we could do. Like this shows, this walks you through the entire algorithm, and it demonstrates how it might work. So maybe components here could be used where you could generate a specific trace and then play it back into the simulation, and then that way you can explain how an algorithm works, right? So for a DHT and helping to understand how like the DHT traversal would work, this would be super nice because you can just write that and then play it for the person learning, right? So it'd be a way simpler to understand how a lot of these protocols work. Yeah, so I'm going to put the link to this one into this because it's definitely like a much easier way to understand the protocol than reading the paper. But yeah, thank you.